We're going to talk briefly about how acids are named, acid nomenclature. So first we're going to look at this table. On the left you see acids that are what we would call binary acids, where there's just hydrogen and one other element. And so when you look at the corresponding conjugate base of each of these acids, or the corresponding anion, those are on the right. Those are monatomic anions: chloride, bromide, fluoride, and iodide. So we're going to compare the anion name to the acid name, and we're going to see if we can figure out how these acids are named. So here, when we have an "ide" ending, like we do for all of our monatomic anions, then the acid needs to begin in hydro, it's a new prefix, and then it ends in "ic." So hydro blank ic acid. So here we have acids, if we kind of conclude what we wanted to about that, if the anion name ends in "ide," which most monatomic ions, where it's just an atom with a negative charge, like Cl minus or Br minus or S2 minus or O2 minus or N3 minus, so monatomic anions, if it ends in "ide," then the acid name starts with a hydro, there's a prefix hydro, and then the element root goes where that line is, like chlor, brom, sulfur, right? And then it ends in "ic." And then of course you always have to have acid at the end to indicate that it is an acid. So for example, chloride ion becomes hydrochloric acid. Now if we look at another set of acids here, if you look on the left, these are the acid names that go along with, on the right hand side, are the different polyatomic ions that you would have learned last semester when you learned how to name ions. So now let's look at how these compare. If you look at the endings of the anion names and what that corresponds to in the ending of the acid name, then we need to make some conclusions about this. So now we're going to compare these. Here, if this ends in "ite," the anion ends in "ite," then it appears that the acid ends in "ous," us acid, right? Us acid, us acid, us acid. If the anion ends in "ate," however, we underline all the "ates" with blue, and we look at the corresponding acid name on the left, those acids tend to end in "ic acid, ic acid, ic acid. So now we can make some conclusions about that. So if we put our conclusion into words, then if the anion name ends in "ite," like nitrite or sulfite, then the acid name ends in "us," and then of course you have to write acid to indicate that it is an acid. So sulfite is sulfurous acid, and sulfate would be sulfuric acid. And so if the anion name ends in "ate," then the acid ends in "ic," and then of course you write acid to indicate that it is an acid. So if we use the same chlor root, then chlorite becomes chlorous acid and chlorate becomes chloric acid. And finally, the last thing that we need to look at is the effect of prefixes. If the anion already has a prefix, like hypochlorite ion or perchlorate ion, then look at the corresponding acid name. You'll notice that the prefix is still there, right? So the prefixes don't change. So if we add that into our list here, then if there is a prefix in the anion, like you see on the left for hypo blank ite or per blank ate, then that prefix still stays there. So hypochlorite becomes hypochlorous acid, and perchlorate becomes perchloric acid.